So here's the output that SPSS gives me for the general linear model approach to doing a MANOVA. I get my first table with sample size, 209 for undergrads, masters 211, and 199 PhD. So roughly similar sample sizes. Then we get the means and standard deviations, and we can see for verbal 1, the first verbal subscale, the undergrads had the lowest mean, 8.64, masters had the next highest mean, 9.86, and then PhDs had the highest mean on this verbal subscale, 11.53. And we can see the standard deviations are ballparkish in the same area. So this suggests to me that there's homogeneity of variance. And if we can look at all the individual means across all 9 subtests. And we can see that the trend is such that PhDs tend to be smarter than masters and masters smarter than undergrads. And that's true across all dependent variables. Now the next box the next table that SPSS outputs is boxes test of equality of covariance matrices. Now in the context of doing a MANOVA, you do not want this to be statistically significant because it's an assumption in MANOVA that the covariance matrices amongst your dependent variables are going to be the same across all 3 of your groups. In this case I've got 3. So however many groups you happen to have. So if they are not the same, then this significance value will be less than 0.05, and then you're rejecting the null hypothesis, which means that you have not satisfied the assumption of equality of covariance matrices. Now, Box's test of equality of covariance matrix has been very severely criticized, and I would say in the best case scenario, you should use a significance level of 0.005, not 0.05, but 0.005. So because the significance level here is greater than 0.05, the assumption is satisfied. But if it were lesser than 0.005, then I would be rejecting the null hypothesis of equality of covariance matrices. Now, this test is very sensitive to normal distributions, and it's sensitive to sample size. In my opinion, I wouldn't even use it probably at all. Another way to get a feel for whether you've got equality of covariance matrices is to actually estimate the covariances amongst your dependent variables and split it across your 3 groups. So I want to compare my groups across education level. So I'm splitting the file, and then I'm going to go into Analyze and Scale and Reliability Analyses. That's where covariance matrices are found. It's kind of hidden away in there. Statistics and covariances. And this is going to give me the covariance matrices between my 9 dependent variables across all 3 groups. So you can see the covariance between verbal test 1 and verbal test 2 is 3.797 for the undergraduate group, and it's 5.834 for the master's group, and it's 5.037 for the PhD group. All right, the covariance between verbal test 1 and verbal test 2 is roughly the same across all groups. And if you look at all the covariances in the covariance matrices here, they're all roughly approximately the same. And Box's M is trying to test this in a one unit, like by giving us a one number, but it's too sensitive to sample size and normal distributions. And I think another way is to actually look at the covariance matrix. I'm going to look for a number that you can say, as long as no corresponding covariance value is greater than 3 times each other. So as long as they're within 3 times each other's values, the MANOVA is probably going to be pretty robust.